Welcome everyone. In this video lecture, we will draw the stick diagram of a two input OR gate. So basically, for the two input OR gate using CMOS structure, first of all, you have to make a NOR gate. Okay, so we cannot directly make the OR gate. So first of all, we have to make a this one is a NOR gate. Okay, means if the input is A and B, the output will be A plus B bar. Okay. Then after if we put a inverter, okay, or CMOS inverter, then the output will be like this A plus B. So this one is the way for the CMOS implementation of OR gate. Basically, we are doing for the CMOS implementation of OR gate. So very first thing is that we have to just draw the what means NOR gate. Okay, so this one is our NOR gate. Okay, then after we have put it a inverter. Okay, then after we have put it a simple inverter circuit. Okay, so basically this one is our inverter. So this one is the representation for the NOR gate. Okay, okay, so I am writing here NOR gate. Okay, this one is our NOR gate using CMOS structure. Then after we have to make a inverter. Okay, so this one is our CMOS inverter. So these are the two common things. So we can easily know how to draw the NOR gate and inverter. Then after we have to go for the stick diagram. If you make this structure, we can say this one is basically a OR gate having two inputs A and B. Okay, and these two are the PMOS. So I am writing say this one is our PMOS A. So PA, PMOS PB. Then this one is a NMOS. So we can write it NA, NB, and this one will be some PMOS. So I am saying this transistor is a P. Okay, simple PMOS. PMOS. So write it PMOS. Okay, PMOS, and this one is our NMOS. Okay. So now we have to do the or draw the what? CMOS two input OR gate stick diagram. So first of all, there should be a metal line for VDD and ground. So and the metal line color will be blue. I have already discussed in my earlier video. So two blue color line. So this blue color line will be our VDD and this one for the ground one. Okay, then after what we have to do first, try to draw the stick diagram of NOR gate. In last video I have already draw the NOR gate using CMOS structure. So there are two PMOS. So PMOS representation, we need P plus diffusion line. So P plus diffusion, so two PMOS are connected. So we can make like this one yellow line for P plus diffusion and two red color horizontally. If you put like this will be the two PMOS structure. Okay. So now this should be our A and B because these two are connected. So once again I want to repeat. This one is our gate of P of A and this one is our source of P of A. Arrow sign always shows the source terminal and this should be our drain of P of A transistor. Okay. So now this one is nothing but simply gate terminal. So this one is our G of PA and this one is G of S. Oh sorry. Okay. Write it. Source of transistor P MOS of A and it is connected. So right now we can make it like this and this one, this one is our drain of, this side is our drain of PA. Okay, now this drain of PA is connected to the source of PB. This one is source of PB. Okay, so this one is our source of PB, means this one. Okay, and this should be our drain terminal, so we can write it drain of PB. Okay, so if possible better to make it more long. So two NMOS PMOS structure is clear. Sorry, PMOS diagram is over. Then after, just go for this N1. Two NMOS is there. So for NMOS, what? N plus diffusion is required. So make it 2 N plus diffusion using green color. Okay, N plus diffusion, green color. Okay, so I'm making like this. And then two polysilicon line. So like this, we can write it A and B. This green color is our N plus diffusion. Okay, red color is our polysilicon. Okay, once again I am writing here. Polysilicon is represented by the red color. Okay, and this yellow one is called your P plus diffusion line. Okay, so like this, two NMOS is there. Okay, so this NMOS having gate terminal, gate of N of A, then this should be our drain of N of A and arrow sign. So the source of N of A we can write, and this one is drain of N of B, and this one is a source of NB. So source of NB, and this one is simply gate of NB. Okay, so this one is gate terminal. So we can also write this as a gate NA. Okay, this point. This one is gate of NB. Okay, then this side is nothing but simply source of NA, and this one is source of NB, and this one is our drain. So drain of Na, drain of Nb. Now these two are connected, okay, with some metal line. So what we can do, okay, is to be connected. So make a contact with a black color. Okay, here also we have to make a contact. So now we can do. Okay, now there is a output line. So in between output line, so same color, no need to go for contact. So this will be our A plus B bar. Is it okay? A plus B bar. So this one is the correction. Then after what? One CMOS inverter is needed. So for CMOS inverter, what we can do? We can simply make a yellow line. Okay, yellow line. Okay, make it more. Okay, then this one is our PMOS structure, and one NMOS. So make it what? NMOS. Okay, it is connected to VDD. So VDD connected. Then after, one red line for the polysilicon. So now this end is our source terminal for the PMOS. Okay, I am writing this one is the gate terminal of the PMOS. So I am writing like this, and this one is drain of PMOS. Okay, and this one is drain of NMOS, gate of NMOS, and this one is source of NMOS. Arrow signs signify the source terminal. Okay, so this one simply we can write source of source of PMOS. Source of PMOS terminal is connected to supply. Okay, so you just make it contact. Okay, then this one is our simply the input A plus B. So we will do it later, and this one will be our what? This terminal is our drain of PMOS, and this will be our source of NMOS. So I will use red color, so I am writing like this, and drain of drain of NMOS. This one is our drain of NMOS. Okay, and these two are connected together. Okay, so through metal line, Okay, now my metal. Okay, wait. This one is our NMOS, and suppose these two are connected through a metal. Okay, and so we have to make a contact. So we have to use the red color, and then after these two are connected, means the get terminal of PMOS and NMOS is connected. So we have to connect these two to the same line. So there is no need to put the contact, and then this one is connected to input. Okay, this one is connected to input of these two gate. So blue color we can use. Okay, then two different colors, so we have to use a contact. Okay, here also we have to use a contact. Then after, it should be our simply A plus B, because this one inverter, so directly invert. So this is the simple representation, means this one, these are gate of PMOS, gate of NMOS connected together with the output of this side. So like this is the diagram. Okay, so like that we can make the OR gate, AND gate also. So this one is the representation. So we can directly do this diagram, or now in this diagram we have put at everything. If you have to make it more elegant, like without putting all these things, what we have to do, once again I want to show you. Okay, one is our VDD with supply and ground, or VSS should be the blue color. Then after one, see, this one is our two PMOS. Okay, two PMOS are connected together. So one yellow line we have to make. Okay, one yellow line. Okay, so two transistor is there. So two transistor. Okay, then after two NMOS is there in the below, two NMOS. So, and this NMOS in parallel kind. So I am like making like this. Okay, then two polysilicon line. Okay, to polysilicon line. Then try to use a metal for the output. Okay, so what we can do, there should be some contact with these two. Here also we make contact, and then we can directly take the output from this side, and we can write like this as a b a b. So this one is the NOR gate we are getting A plus B bar. Now we have to make it inverter, one inverter. So what we need, again a PMOS and one NMOS. Okay. So one yellow line for the P plus, okay, and green line for the N plus, and these two are the red color for the get terminal polysilicon line with the red color. So this one is the get terminal. Then after you have to contact this point. Okay, and then after we have to take the output from in between these two points. So first better to connect with the blue color metal. Okay, and make some connection, contact first, contact to different color. So we have to make the contact. So here will be also some contact, and we will take the output from this one. So this output will be our A plus B. Okay, so this one is the basically the OR OR gate. Okay, OR gate stick diagram, in which first we have to make the NOR gate, and then we have to make a inverter. So like that we can do. So this one is the generalized way to do the CMOS to input OR gate stick diagram. Okay, so it is very simple, but we have to be very careful about the color. For the PMOS, one green line and red. Okay, for PMOS, one yellow P plus diffusion and red color. Okay, similarly for the VDD and ground, blue color, red color, polysilicon. Okay, and one demarcation line is also there, means if you have to make a demarcation line, so what we can do, brown color line, this line is our demarcation line which will separate the PMOS and NMOS. So here also we can say demarcation line, or better to do it with demarcation line. Demarcation line. So this is all about this video, and this one is very easy, but you have to practice. Okay, so this is all about the two input OR gate representation using the CMOS structure and their stick diagram. So this is all about this video. Thank you for watching this video.